Alright, in chapter 7, section 1, we are going to graph an exponential function. An exponential function is where you have an equation where the variable is in the exponent. That's why I call it exponential function, because the variable is in the exponent. Alright, so here's the general form of an exponential equation. There's some key characteristics you need to know when you're graphing an exponential function. First thing you need to find is the y-intercept. Alright, remember your y-intercept is when x is equal to 0. Alright, so it has 0 and then whatever your y coordinate is. That is your y-intercept. Next thing you know, you need to tell me, is it increasing or decreasing? Right? When we're talking about exponential functions, when you got equations that look like this, increasing in the real world usually call it growth. Right? Like interest rates, those are exponential functions. Decreasing, they call it decay. You get a lot of this in chemistry, like you have a half-life of isotopes, bacteria that can decrease over time, or you have bacteria that can grow over time. All of that kind of, a lot of your chemistry problems, or a lot of chemistry has a lot of exponential functions involved, because increasing and decreasing all depends on what you are talking about or working with. And the third characteristic that you need to know is you need to find the horizontal asymptote. Alright? And so I'm going to do two examples, and I'll help you determine this stuff, and then we'll graph. Alright? So let's look at the first example. This is an exponential function. Why? Because there's the variable that's in the exponent. Right? That makes it exponential. So right there automatically means, and go back to here, that your graph will either look like something like that, or it's going to look something like that. Okay? This is increasing, this is decreasing. Right? Because remember, you go from left to right, and as I go from left to right, I'm increasing. If I'm going from left to right, I'm decreasing. Alright, so your graph is going to look like one of these two forms. Alright? Alright, the first thing you know, if it's increasing or decreasing, you look at that term. Remember, y equals ab to the x. In other words, a. If a is positive, it's increasing. If a is negative, it's decreasing. Simple as that. This is positive 1/2, so I know my graph is going to look something like that. Right? So, first key characteristic is it's increasing. Alright? The second thing I want to find is my y-intercept. What is my y-intercept? Alright? Well, to do that, you make a little table. This is your x. We make x 0. You plug 0 in for x. Alright? So in other words, we have y is equal to 1/2 times 3 to the 0 power. Well, my rules of order of operation says I got to do the exponents first, so 3 to the 0 power is 1. So now this becomes 1/2 times 1, and 1/2 times 1 is 1/2. So my y-intercept is at 0, 1/2. Alright. And now my third characteristic is, where is my horizontal asymptote? In other words, what it's asking, where is it undefined? That's what they're asking, right? So, right now, probably the easiest way of figuring out this is we go ahead and let's graph with what we do have. All right. So we'll make this 1, 2, 3. Right. Negative 1, 2, 3. 1, 2, 3. Start out easy. All right. So 1/2, 0, 1/2. There's my y-intercept. My graph is going to look like this, so it's going to probably go something like this. Right. So in order to do that, let's figure out 2 more points. All right. I'm going to pick a point on this side of the y-axis, and I'm going to pick a point on this side of the y-axis. So let's actually use 1. So if I put 1 in for x, so that says put 1 in for x here. So it gives me y is equal to 1/2 times 3 to the first power, which is 1/2 times 3, which is 3/2, or approximately, or that actually means 1.5. All right, so I'll go to 1. Here's 1.5. Let's pick one over here. Let's pick -1. Okay. So put 1/2. Move this up. 1/2 times 3 to the -1. So that becomes 1/2 times 1 over 3, because that's what the negative does. It takes the reciprocal of 3, so it becomes a fraction now. So now this is 1/6. And 1/6 is, use a calculator, is approximately 0.2. Right? So -1.2 is just barely above the x-axis. Right? So you can see how my curve is. So I'm just going to go ahead and curve it like so. Right? So my horizontal asymptote. For the most cases that you will come across in this section, as of right now, we're looking at the basic introduction of exponential function, is that the horizontal asymptote will always be the x-axis. In other words, no matter what number I put in for x, if I put in -100, this will still end up being a positive value. There's no way that this exponential function can be negative. It's impossible. Because if I put a negative for x, all this does is makes this a fraction. And a fraction times a fraction is a fraction. All right? It never changes signs. All right? So that means it will never, ever cross the x-axis. It's impossible for this equation. The only way that, all right, I was going to start saying something else. I can't, never mind. So that means a horizontal asymptote is the x-axis. It's increasing function, because from left to right it increases. My y-intercept crosses the y-axis at 1/2, and my horizontal asymptote is the x-axis. So in other words, my graph cannot touch or cross the x-axis. Now it looks like it's touching here. That's all right, because I'm using a thick pen here. If you're using a pencil, just draw it as close as you can without touching the x-axis. All right? That is exponential functions. So let's do one more. Let's do this one. All right. So first thing, let's go ahead and find the y-intercept. Actually, let's determine if this is increasing. We'll do the key characteristics. Is this increasing or decreasing? And remember, look at the form y equals ab to the x. So 3/2 would be our b. Here's the x. So that's negative is a. So a is negative. So that means my function is decreasing. All right. So it's decreasing. So in other words, my graph is going to look something like that. Let's find the y-intercept. So that means we make x 0. So if x is 0, so put 0 for x. So that means this whole thing is to the 0 power. So that means it becomes 1. And you get the negative in front, so it becomes -1. Okay. So we can go ahead and start. There's our y-intercept. So let's go ahead and start graphing this, at least the first point. Right, let's keep it simple. We're going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 0, -1. Oops. 0, -1 is right here. All right, so now it's going to look something. That could be. I'm sorry. That is decreasing. Also, it could look something like, whoops. Never mind. All right, so I'm gonna brain fart here, but that's all right. Now let's pick a point on this side of the y-axis and this side of the x-axis. Now, right now, I can tell you what my horizontal asymptote is. It's going to be the x-axis. No matter what value I put in for x, if I put in a positive value, this will be positive, always be positive, and then this will make it negative. So it will always stay below the x-axis. If I put in a negative value for x, negative value means this flips. It doesn't change the sign of it. It still stays positive, but it now becomes 2/3 or whatever what x is, but then the negative front will still make it negative. So this right here is impossible to become negative, because in order to go above the x-axis, this right here, what's in the box, has to be negative, because negative times a negative is a positive. That's never going to happen, because the negative exponent makes it a reciprocal, so it changes, it flips it. That's all it does. So my answer will always be negative. So my curve will always be below the x-axis. So this is decreasing. So if I draw a graph looking like that, it's going to cross the x-axis, so that can't be correct. So that means the only way that this could be a decreasing if it goes like that. And so from left to right, it decreases. That will probably be the best case. All right? So here we go. So let's put 1 in for x. If I plug 1 in, so that's 3 halves. So the first power is 3 halves. Now it makes it -3 halves, which is -1.5. So we'll go to 1, -1.5 is right there. Let's go to -1. -1 for the x makes this, when you have a negative, then a negative exponent flips this, so it becomes 2/3, and that's -2/3. So therefore, that is -0.7 approximately. So here's -1, and I'm going a little bit more than halfway, so I'll be somewhere in there. All right, so now we just go ahead and connect the points, and there is my exponential function that's decreasing. All right. So your graphs will either look like, get rid of this, will either look like this, or it will look like this. I'm getting 2 graphs on here. All right. Increasing where it stays above the x-axis, decreasing where it stays below the x-axis. So that's what your graphs will look like.